Hey everyone, welcome back to my channel StudyByte. In this video we will learn about what is data models and schemas, instance, and also three schema architecture, data independencies, database language, database interface. These are the main thing we will learn in this video, and this is the third video. I hope you like it. Let's begin without further wasting any time. So let's start. So basically, what are data models? What are data models? Our data models means how we plan and organize data, how we plan it, how we plan the uh, data in a form of like organized way. So this is the thing that data is organized, and how they are organized. It is known as data model. How we plan and then organize data. It's simple as that. Just like we decide how to arrange, for example, books, how to arrange books from one to another. So arranging a book in a cupboard is an example of data model. Types, let's discuss about types. This is a data model. Basically, just now I have told you. Simple as that, how we plan data and organize the data is known as data model. Now, let me move to next part, type of data model. So, types of data models are conceptual data. First one is conceptual data, logical data model. Third is physical data model. So, uh, what do you mean by conceptual data model? Uh, like drawing a map of how things are related. For example, for your more understanding, a student belong to a class. So it's a conceptual model. So like we know drawing a map of how things are related, how they are related in the map is known as conceptual data. Let me deep dive deep into this part. Describe the high level structure of database and uses entities and relationships. Just now I have already told example. Uses relationships like a student belong to a class. So it's a relationship between student and the class. It's conceptual model. Another one is logical model. What is logical model? A logical model is nothing but turning the map into tables and columns. Instead of relationship, they use physical storage. Independent of physical storage, they use table, column, and keys. So, like a table, we have a table. In the table, we generally have columns and rows in it, right? So this is one of the example, or we can see if you want. If I want, the examples are, for example, student. Uh, Let me just student. Suppose we have students in this data. In this students, so the student has name, roll number, and class. So that's a rows and column in it. Simply as that. So logical data model is nothing but it represent in the form of table and columns. Let's move to another part of data models, which is physical data model. Physical data model is nothing but how computer actually store the data on disk. Means physical storage of the data in disk is known as physical data. So this is not a physical storage. This is like a logical, we need stable like structure storage. So we cannot say it's a physical storage. Physical storage is like disk. uh, a table that we store in disk is a physical storage. So that's why it's called physical data model. Physical is like physical, we can see it when, and we can just like feel it and what's the main part of it. We cannot just yeah, that's a physical data model. Now we have covered all this. I hope you have understood each of this. Data models, this is the part, these are the part of data models. Now another one is schemas and instance. So schema, what is schema and what is instance? Let's talk about that. Schema, the plan or structure. Basically, it's a blueprint. It's a structure, basically. Structure in the sense it's a map of something, blueprint of something, something. In terms of something, I mean database. Database is blueprint of database. And what is, for example, the design of the student table is a plan or structure of database. Now, instance. What is instance? Instance is nothing but the real data inside the plan. The 100 student entries currently stored means instant of time. Means the time is like uh, if we have a time, so at instant of time, it's known as basically instance. Instantly. That's the main thing. Okay, now these are the example that I have already told you. So we have covered a lot of things. And now three schema architecture. So what is three schema architecture? It's a combination of three things. First, external, external level. Second is conceptual level. Third is internal level. Now let's discuss about these three levels that are present in three schema architecture. Let's see. So firstly, uh, what each external, what each person sees. What each person sees means it is customized view. For example, student sees book like list only. Teacher sees full detail. So what each person sees depends on it. It's external one. Like for student, it should be like a list of books, but for teachers, it's a full detail. So different people have different external level, conceptual level. The full organized design of library. It's a fully designed or an organized design of library. Example, like all books, all shelves, how things are arranged. It's a all organized way, fully organized way, conceptual. Internal, how book are physically stored, means physically how they're stored. Uh, for example, shelf number, box number. If we have a box, so there is some kind of number in it, like one, a two, and so on. So it's basically physical storage details in it and the actual place. So data is being differently by different people, but stored in one place. Okay. What is data independencies? Changing storage style should not affect user. So basically, changing one level of data without affecting the other levels. It's an ability to change one level of the database without affecting the other levels. Other level is not affected by changing the levels. Let's discuss about the types. Logical data independencies. Logical data independencies. So it's something like change in design does not change what users see. Yeah, you exactly heard right. Change in design does not change what users see. Means design does not change what users see. Design is not depend on the users that they can see. So it's a conceptual model. So yeah, do not affect user view by changing the design. Means design is not changed. So yeah, it's conceptual model. And physical data dependency is like change in storage method does not change design. Changing the storage method is changed but does not change the design. Design is not changed, but the storage is changed. So by changing the storage, it means there is no effect in mm, change design. There is no change in design. So this is data independencies. So now we will move to our database languages. There are different type of languages present in database. First is DDL. DDL stands for data definition language. The data definition language. So meaning in simple words are change in design does not uh, means let me give you a brief introduction, or we can say it meaning make or change tables. So next is DML. DML stands for data manipulation language. Data manipulation language means put or change data, like update command, in the insert command, delete command, and also select command. Basically, changing the data is known as put or change the data. DCL. DCL stands for data control language. It basically give permission, allow teacher to view records. Basically, control access permission. These are the command we can say. We have grant revoke that give the permission to view the record. Now let's move to another database language, which is the language is TCL, transaction control language. Transaction control language. It means save or undo changes like commit, rollback, and save point. It saves the changes and undo the changes. This is TCL. Now we will move to another part of it, which is database interface. Database interface. What is database interface? It means interface means how we use the DBMS. Common way of user interface with DBMS is GUI interface. Click and use makes it easy. Command line. Command line is like type commands like MySQL and CLI. MySQL CLI. Uh, Now we have application program interface. It is like API is like something used by programmers to connect app to database. It basically connect the app to database so that user can easily access the database by connecting with database uh, with app.